Alright guys, this is just a summary of the cylinder, cone and sphere. The first place to start is in your formula maths tables and look carefully what it says here. Okay, so you've got the cylinder, the area is 2 pi r h, the volume is pi r squared h, and in the cone we're given that the area, and that's only the bit around the side here, is pi r l. And then we have the volume is 1/3 pi r squared h, and the sphere is there as well. You can read it there yourselves. Just be very careful when it comes to writing down the formulas. I see lots of mistakes made here. 4/3 pi r cubed is what it says. Anyway, back over to here. So there's the formulas again. Again, this bit here is pretty important. Put a little circle around that. 4/3 pi r cubed. Surface area is 4 pi r squared. The hemisphere. Now, a hemisphere is half a sphere. So the formula for the hemisphere isn't given in the maths tables. But if you think about it, the volume will be half that of a sphere. So you don't really have to remember that it's 2/3 pi r cubed. Just get the volume of a sphere of the same radius and divide it by 2. For the surface area, again, if you half a hemisphere, you'll get this curved part here. All around here. That's all the curvy part. But then, of course, you're left with a circle on top after cutting the hemisphere in half. So that's pi r squared. That's where this 3 pi r squared comes from. And then down along to the cone. The volume, again, there's the formulas. There's all the information there. For the total surface area, though, obviously the base here is just a circle, so it's going to be pi r l, the curved part around the side of the cone, plus the circle at the base. Now Pythagoras' theorem is really important here, and they mightn't necessarily be labeled L, H and R on an exam paper or whatever, but it's just your standard Pythagoras theorem. L is the slant height. Make sure you don't use that when it comes to finding the volume. The volume uses the perpendicular height and the radius. And here's just some examples I cut out of your textbook. So a nice example here. Again, be very careful, read the question carefully. Are you given a diameter or are you given a radius? In this case, you're given a diameter. So here we're going to use radius equals 8. And then you just plonk them into the formulas. 4/3 pi r cubed. Now most of the time, they don't actually give you a value for pi. You can use pi in your calculator or 3.14 or whatever one you want. They tend to ask you to give an answer to whatever, maybe 1 decimal place. And then the next example here is the cone. Starts off pretty nice. They simply ask you to get the volume, use the pi key on your calculator, find correct 1 decimal place. Again, it'll probably just say in an exam paper, find correct 1 decimal place. So we need to know, to get the volume anyway, first of all, we need to know what r is, and it's given to us here. And we need to know the perpendicular height. And then we can go straight away and do the volume. Nice question. For the curved surface area, we're not given the slant height. So this is where we use our Pythagoras' theorem. And it turns out to be, well, it's one of those nice ones, Pythagorean triple, where you get a nice whole number for the hypotenuse here, and it turns out to be 13, and then you just go and use the formula pi r l, and you get pi times 5 times 13, and it turns out to be 204.2. Now, a fancier question here maybe. How do you cope with these ones? Well, we have a metal cylinder, radius 5, height 12, not drawn very well to scale. But anyway, that means we can actually go and find the volume of this thing here. And the cone is, we're just told, radius 10, height h. So we're told it's melted down. Let the volume of the two of them equal each other. Fill in everything you have. End up with the equation there. And you end up with a height of 9. Now I have to stop because I have a 5-minute limit on this. Thank you for watching.